So we're picking up with our discussion of IP addressing. We've just talked about binary addressing. Now we're going to move on into the network classes. The first class of network we're going to talk about is a Class A network. And a Class A network is a very, very large network. It is a /8 network, meaning that the first bit is always 0, so the network ranges are 1.0.0.1 to 126.255.255.254. Each of those Class A networks, 1.0, 2.0, all the way up to 126.0, that is an entire Class A network, which means you have somewhere in the range of 16 million possible IP addresses in each of these Class A networks. Again, we're going to talk about the first bits in the network address, and that harkens back to our discussion of binary networking. The next class of network is a Class B network. Those are medium-sized networks. They're /16 networks in Cedar notation. The first two bits are always 1.0, which means the possible network ranges are 128.0.0.1 to 191.255.255.254. Say that 5 times fast. The third type of network is a Class C network. You can kind of sense the pattern here, can't you? The Class C network is lots of small networks. These are the /24 networks that you probably have run across if you've dealt with any type of small network, or if you've dealt with a home network. By default, they come with a 192.168.1.0/24 network, so if you've just used its default configuration, you're using a Class C network. The Class C network, the first 3 bits are always 110, which means the possible network ranges are 192.0.0.1 to 223.255.255.254. Moving along to the Class D network, these are multicast addresses, and we won't really talk about multicast very much in the CCENT, but a lot of routing protocols and other layer 4 protocols use multicast addresses. Multicast is where you take one packet, you send it to a special address that's in this Class D network range, and multiple machines can receive it on a network if they're listening to that multicast address. It's different than a broadcast address. If you send to the broadcast address, every machine on the network has to receive the broadcast and has to process it. Whereas multicast addresses, not every machine has to receive this multicast. Where you'll see multicast used a lot, besides routing protocols, is streaming video. If you have a streaming video server and you have multicast clients, that way you can only send one packet across the network and have 15, 20, 30 machines all watching the same video feed. The first 4 bits of the Class D network are always 1110, which gives us possible network ranges of 224.0.0.1 to 239.255.255.254. You can probably guess which network is next. It's the Class E network. Class E networks are experimental. You'll never see these out on the internet. These are really used just for the IEEE to play with networking fundamentals, with new networking topologies and whatnot. The first 4 bits are always 1111, which means the network ranges are 240 up to 255. Like I've said, they're never assigned to internet hosts. So now let's talk about some special address classes that are outside those Class A, B, C, D, E networks. The first one we'll talk about is the automatic private IP address, and you've probably seen the automatic private IP address if you've ever dealt with a network that wasn't working properly. APIPA addresses are used when a DHCP configured workstation can't contact a DHCP server and can't lease an IP address. Now, they're supposed to use these APIPA addresses. Some flavors of Windows will actually just use the last private IP address that at least whether or not it can talk to a DHCP server. That's technically against the RFCs, but it's so widely used and so widely accepted that no one really cares. The APIPA addresses are in the 169.254.0.0/16 network. So that means by default, if you have a bunch of machines that don't have a DHCP server, they'll all get assigned addresses in these ranges, and they'll all be able to talk to each other on a layer 4 level. Now again, these addresses are non-routable. Most internet routers, if not all internet routers, will drop addresses in this range because they realize they're special addresses. They're not to be used for actual internet hosts. The next set of special IP addresses we'll talk about are the private IP address ranges. And again, if you've dealt with any networks, you probably have seen these, but you didn't know why these networks were picked, or you may not know why these networks were picked. They are defined by RFC 1918. And if you're a really big nerd, you can go out and read the RFC 1918. They're freely available. And you can see the logic and the reasoning behind using these address ranges and a whole lot of high-level geekery that I don't even understand most of it, to be honest. But all you really need to know for the CCENT is that these are addresses reserved for non-internet connected networks. Again, like the APIPA addresses, if most internet routers see them, they'll just drop them because they'll assume you're trying to attack them by giving them a non-routable source IP address. Those are the network ranges 10.0.0.0, 172.16 to 172.31, and the entire 192.168 network range. Again, these are within the various existing classes, the Class A, Class B, and Class C networks. So you can have an entire Class A network assigned to your internal network if you want to, just by using this 10 dot. Or you can have a bunch of Class Cs defined by 192.168, 1, 2, 3, so on and so forth. There's another class on here, and I've got this little cheesy doormat here. This is the loopback address range. It's 127.0.0.0. By default, 127.0.0.1 is the local host or the home address, so this doormat here is basically a nerdy way of saying there's no place like home. Hey, everybody's got to have a little humor now and then. And that concludes our discussion of IP addressing.